Ladies and gentlemen, welcome to Analytical Seminar number 34. The subject of this seminar is Fundamentals of Energy Harvesting for Distributed Power Sources. This seminar is presented by me, Siri. Enjoy the seminar. Motivation for energy harvesting among distributed power sources. Existing architectures of satellite power systems already adopt distributed solar array sources. Each array source is interfaced by its respective DC to DC converter power channel for power processing into a common system output voltage. Maximum power tracking controller for the distributed array sources should be made simpler since their peak power voltages are similar. There exist three possible approaches of energy harvesting. First, draw equal current from each source using uniform current distribution UCD. The control of all distributed sourcing current. Group tracking uniform current distribution or GTUCD. The second approach is keeping equal voltage across each source using uniform voltage distribution control of all distributed sourcing voltages. Group tracking uniform voltage distribution or GTUVD. And the third approach is independently tracking peak power voltage of each source using independent maximum power tracking IMPT controllers. Each of these controllers is dedicated to each source. The approach number one, which is group tracking uniform current distribution, is the worst approach. The voltage across individual power sources are not controlled, despite the nearly equal peak power voltages of the distributed power sources. As a result, the achieved peak power is often too far below the ideal peak power. Disadvantage of the group tracking uniform current distribution is delivers far from optimum power, particularly when the sources are not identical, or the source possesses different peak power currents. The best approach is independent maximum power tracking or IMPT. In this approach, the ideal power is achievable since peak power voltages of individual power sources are independently tracked. The pro and con of the independent maximum power tracking harvesting approach. The disadvantage: this IMPT leads to the most control complexity. The advantage is the IMPT allows the ideal peak power to be obtainable as a summation of all available peak powers being harvested from all power sources in the system. The approach that we are considered as the main focus of this presentation is group tracking uniform voltage distribution, which is at the approach number 2. Only one MPT controller is used to track the system peak power voltage despite different peak powers among individual power sources. Uncontrolled uniform voltages is achieved across individual power sources. Feasibility of the group tracking uniform voltage distribution harvesting approach. Group tracking UVD provides a nearly ideal transfer of the optimum power with less control complexity and ability to preserve power fault tolerances. Distributed power source and distributed input parallel output converters or dipole converter are controlled to achieve their input voltages across their respective power sources and track the system optimum power point, which is sufficiently close to the ideal system peak power. Let's understand the definition of the optimum power transfer in the group tracking uniform voltage distribution. System optimum power is by definition the maximum power drawn from the distributed power sources while keeping their equal voltages. With proper input voltage distribution control, an optimum utilization of power sources is achieved by using only one controller for MPT and eliminating distributed independent maximum power tracking controllers, each of which is conventionally dedicated to its respective power source. These slides show the plot of the PV, which is power versus voltage, DC characteristics from the three approaches of harvesting energy. The base approach is independent maximum power tracking, provides 842 watts, which is corresponding to nearly 100% tracking efficiency of the ideal peak power as shown on the top curve with the highest peak. The worst approach is group tracking uniform current distribution, delivers only 88% tracking efficiency or around 730 watts. The optimized approach, group tracking uniform voltage distribution, which is the main focus of this presentation, delivers 98.7% tracking efficiency. This slide shows the simulation result providing the transition between lower peak power point of 1170 watts to the upper peak power point of 1357 watts as a result of the sourcing circumstance that change from the identical sourcing voltage of three power source on the lower curve to the different sourcing voltage of the upper curve by sourcing number 1 have the 80 volts and sourcing number 3 have lower voltage drop to 50 volts while sourcing number 2 remain the same at 60 volts.